So we're starting on Unit 7 with this video. Here's a list of the topics we're going to be covering by day. The overall theme, the big topic for this Unit 7 is talking about functions. So we're going to be reviewing some of the functions we've already done. So we'll be doing tomorrow. And then we're going to be adding in a few more new functions the next couple days. And also talking about some different ways we'll see functions and different properties of functions. So that's what we'll be doing in this unit. We're starting today with just basic definitions for functions. The first thing is talk about what a function actually is. So to do that, first we have to talk about a relation. So a relation is any set of ordered pairs, right? Or really is any set of input and output values. Or really any set of x's and y's is a relation. A function is a special type of relation. A function is a relation where we have every input paired to exactly one output. The way we say that is every element of the domain is paired with exactly one element from the range. Right, so in that definition we brought up two more terms, domain and range, right, which we've already talked about. Domain, we know, is all the x values a function can have. So in terms of these definitions, the way we define domain is the set of all possible input values for a relation. Right, which means all the x's. The range then is the set of all the output values. So basically domain is all the possible x's we can put into the function and get a number back. The range is all the numbers we get back when we put those x's in. And what this definition is saying basically is that every x has only one y it's paired with. Right, so every x is paired to only one y. Right, and that allows us to evaluate a function. If you put in x, you get one number back for y. So there's a couple different ways of telling if a relation is a function. So here's a relation at the top in this example. Relation is to any set of ordered pairs. We can tell if it's a function in a couple different ways. One way is to use what's called a mapping diagram. So a mapping diagram is showing how a function works, or a relation works. A relation maps the domain onto the range. Maps domain to the range. So we can illustrate this with a picture called a mapping diagram. Again, the domain is all the x values. So if I look at all the x values I have up here, I have 1, 3, 4, and then 1 again. So 1, 3, and 4 is the domain for this relation. The range is all of the y values. So 2, 4, 2 again, and negative 3. The mapping diagram shows which x's are mapped to which y's. So I have on the first point 1, 2, 1 is mapped to 2. Then I have 3 mapped to 4. I have 4 mapped to 2. And then I have 1 mapped to -3. So looking at this mapping diagram, we can tell this is not a function. Right, and the reason is because 1 is paired with 2 different y values. It's paired with 2, and it's also paired with -3. Right, so we have 2 outputs for 1. Or we see 2 arrows coming off the 1 in the mapping diagram. The other way we can check to see if it's a function is to use the vertical line test. So the way we do that with the vertical line test is we look at a graph of the relation. So if I draw my axes, I have for my domain 1, 3, and 4. For my range, I have 2, 4, -3. Then I can graph all these points and use the vertical line test. So 1, 2 is the first point, then 3, 4, 4, 2, and then 1, -3. So the way the vertical line test works, if you take a vertical line and slide it across the graph, if it's ever touching more than one point at a time, it's not a function. So right here when I get to 1, I'm touching 2 points at the same time. So it's not a function. The next thing we're talking about is how we find an inverse function. This is what you'll be practicing a lot in class, is how we find the inverse of a function. So the inverse of a function will map the range back onto the domain. Right, so if we have our domain, our range for a function, this would be our original function. For the inverse function, it would be mapping back the other way. Right, so for the inverse function, this would be the domain, and domain would be the range. So we'd switch to have the opposite domain and range. That's another property we've talked about this one before. A function and its inverse have opposite domain and range. Right, so that's how we say it's algebraically, they have opposite domain and range. Graphically, or looking at a picture of the graph of the function, the graph of the inverse is a reflection over the line y equals x. Right, which if you do geometry that has a algebraic rule, we take x and y, and we switch the two coordinates to flip over that line, to reflect over that line. So this is the algebraic definition in red, the graphical definition in blue. It all means the same thing. In plain English, what that means is we want to find an inverse. We just flip x and y. Right, we switch them. So we'll go through a couple examples of how we do that. So here's the first one. This is notation meaning inverse. This -1 means inverse function. So find the inverse function for this function. So I have the function f of x, same thing as y equals 3x squared plus 5. Right, so the first thing I'm going to do is I'm going to switch x and y to find the inverse. So I have x equals 3y squared plus 5. Now if I solve this for y, that will give me the inverse function that I'm looking for. So I have to just solve this for y. So the first step here, I'll subtract the 5. I'm going to divide by 3. And last step, get rid of the square, I'll take the square root. So this would give me my inverse function. Right, we can look on calculator and see that the graphs have this property. The graph on the calculator, real quick, we have 3x squared plus 5. And then on the same window, square root x minus 5 over 3. Right, and again, these are reflections of each other over the line y equals x. So we can see the symmetry about that line if we graph that line. You see the inverse function is missing a piece. Remember, it's a function, so it can't fail the vertical line test. If we want to see the true reflection, we need to take the positive and negative square root. So if we took the negative square root of that same function, you can see the reflection, but it wouldn't be a function anymore. Right, this no longer passes the vertical line test. So for inverse function, it still has to be a function. Alright, so we're going to do the same thing for this next one, exponential function. Find the inverse means the same thing. First thing we're going to do is we're going to switch x and y. So x equals 2 to the y minus 6. Now I just need to solve for y. That will give me the rule for my inverse function. To solve for y, I need to add 6. So x plus 6 is 2 to the y power. My variable now is in the exponent, so I use log to bring it down. Since the base for the exponent is 2, I'll use log base 2. X plus 6 equals y. And that gives me the rule for my inverse function. Log base 2, x plus 6. Remember that exponential and log are inverses, just like square and square root. things like that, you'll see our inverses when you go to find your inverse functions. And their graphs will have that same property of opposite domains and ranges. Last piece of notes for today is even and odd functions. So that's one thing you'll have to know is whether a function is even, odd, or neither. So it's a very easy test. If an even function, if we put in the negative value, the opposite of a number, we should get the same y value back as if we put the original number in. So another way of saying this is it's symmetric about the y-axis. Right, and this rule will work for any x. For any x in the domain of f. For an odd function, if we plug the opposite number in, the y value we get back should be the opposite of the number we get back when we plug that original number in. So this will make more sense when we go through a couple examples. But another way of saying this is that it's symmetric about the origin. Right, again, this will work for any x in the domain. So our test to see if it's even, odd, or neither, we go through the function and we replace x with negative x and then simplify. So if it's the opposite of what we have originally, then it's an odd function. If it's the exact same thing, it's an even function. If it's not either of those, then it's neither. So first one, we have x to the fourth plus x squared. So what we'll do is replace x with negative x. And now we'll simplify. So if we take negative x raised to the fourth power, that's a negative number times itself 4 times, would be positive no matter what. So it'd be x to the fourth. Same thing, negative x squared. Squared number multiplied by itself is going to be positive. And we get the exact same thing we had originally. So f of x same as f negative x. So that means the function is even. Second one's a little bit trickier. We're going to do the same thing. We're going to take x and we're going to place it with negative x. This one's going to be in the sine function. So for this one, we want to think a little bit about what our sine graph looks like. We know period of 2 pi we have one of those points every quarter point along the way, starting from 0. Our pattern goes 0 max, 0 min, 0. If I graph a second period of that, starting from the previous cycle, would start negative 2 pi, 0 max, 0 min, 0. Right, I can see this pattern. When I'm at positive x versus negative x, I have the positive value versus the negative value. And that's true if you look along, that'll hold for any point. Positive or negative x, they'll have the same, they'll have the opposite y values. We plug in the opposite number for x. So we simplify this, the sine of negative x is negative sine of regular x, where it's the opposite of what we started with. So f, we plug in the opposite of x, is equal to the opposite of what we get when we plug in x. So that makes it an odd function. Or we can look at the graph, we see how it has this symmetry with respect to the origin right here, how everything is symmetric about that. That's another way of telling by looking at the graph. This is something with the even and odd functions. The more you practice it, the more it'll make sense. You just have to get some practice, some facility with simplifying all the different types of functions. If you want to look for any other videos about these same topics, you can look for inverse functions for those last two slides, or for this slide, even and odd functions.